Hey little kitty cat, I need you for my science project.
To understand projectile motion, we must first talk about free fall.
Today I'm going to demonstrate to you free fall. They call me the amazing quarter dropper guy. Free fall. That's science.
Free fall is when there is zero air resistance and the only force acting on a falling object is gravity. A good example of free fall would be the moon orbiting the Earth, or a shuttle in space with its rockets turned off.
Here we have a free fall kitty, and he's showing us the equation needed to calculate free fall, which is distance equals 1/2 gravity times time squared, where d is the distance, g is the gravity, which is 9.8 newtons, and t is the time. Maybe free fall kitty used the same equation before he jumped out the airplane. Hopefully he doesn't end up like our other kitty friend.
But wait, what about the horizontal speed?
Yes, velocity.
Velocity is simply a measure of distance covered over a change in time. The equation is v equals d over t, where v is velocity, d equals distance, and t equals time.
Let's it go!
So what is projectile motion? Projectile motion is an object that moves through the air or space under the influence of gravity. It is a combination of constant horizontal component and an accelerating vertical component.
The football throw is the perfect example of projectile motion. Every time the quarterback throws the football, he unknowingly uses projectile motion equation. In an ideal situation, we need to find the vertical acceleration, which is d equals 1/2 times g times t squared, and the horizontal speed, which can be found by using v equals d over t. I think the guy catching the ball is thinking about kittens. What is the history? Well, Aristotle theorized that projectiles with motion traveled in a straight horizontal and vertical drop. Later, Galileo performed an experiment using a bronze ball. He rolled it off the table to find the horizontal motion. He then used the mark of the ball left on the floor to find the vertical distance, thus giving him the horizontal and vertical distance of the ball.
How does projectile motion relate to our degree program? Well, we already know that horizontal motion is constant. We also know that vertical motion is accelerated due to gravity. When you put those two factors together, you have natural motion. There are other factors such as mass and air resistance, but that all depends upon the object. We are in the animation program, so we will have to have an understanding of the natural movement of an object through the air and how fast it falls to the ground due to gravity, such as a ball bouncing. Once we understand these principles, we can exaggerate the animation or even break the rules to a certain extent without the animation looking too unnatural.